Hi all, welcome to our YouTube channel Math Universe with Dr. Naseer Ahmed. Today we are going to start with Kcet on the chapter Matrices. Don't forget that in this Kcet, there are nothing like important 5 marker, 4 marker, 6 marker questions. No, each and every concept, each and every problem level, easy, moderate, and bit more high moderate. I won't say in CET difficult level is there, okay? Moderate, high moderate, that's it. And our target, as we know, that it is 55 plus for 60 marks. And I would like to know how many of you are eagerly ready to work along with me. Make sure comment down. Okay, I would like to surely know how many of you are eager to work for this. And coming back, what I said, there is no 5 marker, 4, 6 marker, nothing, but each and every concept is important. Yes, I will be giving some formulas, some tricks also. Doesn't mean that concepts are not important. Concepts are important. Okay, my motive will be both concept as well as what? Some short tricks as and how we go about. Now coming to the concept. Whatever I have did for PUC matrices, I have completely covered all the concept of PUC. So again, I don't want to repeat it. So you have to make sure, go to the matrices of part of PUC, go through the video. You can go for 1.5 speed, etc. and try to complete and then come back to this video, because those basic things I don't want to again repeat, like starting from definition of matrices, order, then addition rule, subtraction rule, multiplication, all that. I would like to discuss surely that one which is not discussed. I mean, it's a concept about the concept. I would like to discuss those things which are not been discussed in PUC matrices. And if you are perfect with PUC matrices, only then you can follow this. Okay. And again, we can't be choosy. I want that only, I want this only. Don't forget, if we are choosy, success is not ours. If we want success, we should stop being choosy. I should learn each and everything. Okay, and I will be going for more number of problems. Now let us move on to some of the concepts which is not discussed in PUC part. Now here, see, we discussed about diagonal matrix in which non-diagonal elements are zeros. So coming to diagonal matrix, I want to highlight some of the points. This all will come under concepts. So diagonal matrix. Now coming to diagonal matrix, as you know, non-diagonal elements are 0. So if I have got A is equal to, let us suppose A1, 0, 0, 0, okay, like this moves on, then 0, then here let us suppose A2, then 0 moves on, like this. We have a matrix of order n cross n. Now in short, we are going to write this one as, we also write this one as DAIG, diag of A1, A2 up to AN. So the elements present here all are diagonal elements. Okay, nothing but A11, A22, A33 up to AN. Now if this is given, so both are same. If this is given, then let us suppose you want to find whatever power you want to multiply. For only diagonal matrix, you can just raise the power for each of the diagonal element. Only for diagonal element, you can raise the power. Okay, this is the last term, this is the power. Okay. Similarly, this is the first point. Second point, we know invertible matrices, correct? No? For invertible matrices as well, if at all I want to find the inverse of this, just I have to raise what? For all the diagonal elements, I have to raise power -1. That's it. Okay. Next, this let us say point A. Coming to point B. Okay. There's a point 1. Okay. Now point 2. See carefully. Let us suppose that we have got two diagonal matrices. One diagonal matrices is this A1, A2, A3 and moves up to AN. and we have one more diagonal matrix B where addition is not a problem. Okay, B I will take for this, B1, B2, B3 up to Bn. Then how are you going to first part add? First take addition also as well as subtraction also. Very simple. As you know, you have to add corresponding element, but coming to diagonal matrix, other than diagonal element, remaining all are 0. 0 plus 0 is 0, 0 minus 0 is also 0. So we can just think of adding and subtracting the diagonal elements. So the answer will be diag of corresponding element. Okay, A1 plus or minus B1. This plus is for the addition, minus for subtraction. Similarly, A2 plus or minus B2, then A3 plus or minus B3, like this, AN plus or minus BN. Similarly, let us suppose multiplication. I want to multiply. This is only true for what? Diagonal matrices. That you are just going to multiply the corresponding elements. So it will be DAIG, diag of A1, B1, comma, A2, B2, comma, A3, B3, and moves on up to AN, BN. Let us have a bit elaborate here. I have a doubt how many of you really understood this. For that, let us write matrix B also here. So matrix B is actually here B1, then 0, 0, dot, 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 0, then 0, B2, then dot, dot. Like this, we have all the entries going on. So yeah, here also 0, 0, dot, dot, dot. Okay, then Bn. So only non-diagonal elements are zeros. Okay, the other way of writing this one is what? B is equal to what? Diag of B1, comma, B2, comma, B3, and moves up to Bn. Okay, so having this, okay, same thing now here. When I say addition, so it means what? I'm adding corresponding element A1, B1 plus comma, A1 plus B1, comma, then A2 plus B2, like this, moves on, and last term with last term. Similarly, subtraction and multiplication. So let us do one thing. Let us write this how it looks like in matrix, this presentation. So after adding for A plus B, we are going to have, see, we are adding this two term, right? So A1 plus B1, 0, 0. Then 0 here. A2 plus B2, then again 0. Okay, like this it moves on. Then the last row will be all 0, but the last element will be AN plus BN. That's it. If I have minus here, there will be a minus. That's it. So in place of writing like this, we wrote in this manner. Similarly, if you go for multiplication, just it is what? Corresponding element. You can go for usual multiplication. You will see yourself, since the remaining elements are 0, it will ultimately come to this. This one I have discussed in detail in PUC. Okay, B1, then 0, 0, dot, then 0, then here A2, B2. That's what you can see now. This corresponding element we are going to multiply. This corresponding element we are going to multiply. Okay, 0, then moves on, then 0 here. Again, give a dot. Like this, it will continue. And now lastly 0, 0, 0. Lastly it is AN, BN. So this will be the matrix multiplication for diagonal matrices. So we can write like this also, or like this. And be careful with the notation. Now it is not something like I can avoid. Who knows in examination, in place of giving like this, they might have given this, and you have forgot that this stands for diagonal matrix, because in diagonal matrix non-diagonal elements are 0. So they are specifying what? Only the diagonal elements. Okay, so kindly make a note of this. Okay. Okay, let us have an example also. I think example will make you understand still better. Let us suppose that if I have got a matrix A is equal to 1, minus 2, 0, 0, and we have a matrix B 7, 8, 0, 0. Addition, subtraction, not a problem. I want to only talk about multiplication. A into B. How are you going to multiply? First of all, this is diagonal matrix, so I can just multiply corresponding element. 1 into 7, 7. 0 into 0, 0. 0 into 0, 0. Minus 2 into 8 will be minus 16. Job done. And you will also see it is commutative. Whenever it's a diagonal matrix, it's also what? Commutative. A into B same as B into A. Okay, kindly make a note of this. Okay, dear students, let us start with the problems. The first question, as I said, no, I would like to go for easy, moderate, okay, high, moderate. Difficulty is not there, okay, in CET. Now, question says, if the matrix A has 8 elements, which of the following can't be its possible order? Okay, which of the following can't be its possible orders? Options are given here. Now, coming to the solution of this, first recall the concept. If I know that the order of the matrix is m by n, then the number of elements are given by its product. So, it means option by option, multiply to get the number of elements, and that should match with what? 8 elements. Okay, now just see, if I multiply 8 into 8, 64. But they want only, they have given a matrix of having 8 elements, but I have got 64 elements. So very clearly they ask, which of the following can't be the possible order? Option A is correct. No sir, I want to cross check the remaining. Fine, cross check. This will be 1 into 8, 8. 2 4s are 8. 4 2s are 8. All these are the number of elements, 8. So this can be the possible order. But they want can't be. So option A is the one correct for this problem. Option, correct option. Come to second question. Write the number of all possible matrices of order 2 by 2 with each entry 1, 2 or 3. See, I want a matrices of order 2 by 2. So 2 by 2, when I say one element here, one element here, one element here, one element here. So if I just recall with permutations and combination, I have to just arrange these 3 objects in these 4 places. Let us go with this box and show you can refer permutations and combinations. Just recently I have uploaded the video. Detail I have explained the concept. Now see this. Why 4 boxes? Because here 4 like a location we have got. Okay, vacant places. I have just taken in this manner. Now this should be filled either by 1, 2 or 3. So this particular box can be filled by either 1, 2 or 3. So any number, any one of the 3. Surely here repetition allowed. Sir, how can you say? How many elements we have here? 3. How many vacant places are there? 4. So surely with repetition only. Okay. And then here also, let us suppose out of 3, 1 gone. But again 3. All 3 can come here. Again all 3 because repetition allowed. So again these 3 elements can be from here only. So by fundamental principle of counting, multiply them. What is 3 into 3 into 3 into 3? It is 3. 3 is 9. Again 3 is 9. 9 9s are 81. Option C is correct for option. Option C is correct for question number 2. Now let us move on to third question. Construct a 3 by 2 matrix whose elements are given by this. No need to solve each and every. Just go here. See which entry is different, and before that 3 by 2 in all the option order is 3 by 2 only. Now check which particular elements are different. If you just see carefully now, you see this 2, 7, half, 1. These entries are different. So let us find the element, only that element. What's the location of this element? This is in second row and first column, nothing but A21. So just find A21. So A21, nothing but I is equal to 2 and J is equal to 1. So I'll get half of mod I value is 2 minus 3 times of J value is 1. So value will be half of 2 minus 3 ones are 3. 2 minus 3 is minus 1. What is mod of minus 1? 1. 1 into 1 is 1 by 2. Okay. The element in the location second row first column is half. Half is there, yes, in option C. Therefore, option C is correct. Mind it, this is not shortcut. This is the concept. Since we know from the concept what is the location of that particular element, we are able to solve. And one more thing, all our properties of this chapter will be serving as a shortcut. Okay. Make a note of this. Okay, dear students, let us move on to next problems. Question number 4. If A is a matrix given by this and B is this, then the value of this we have to find. Options are given. See, this is completely based on the concept A11. Nothing but first row, first column, B11, first row and second column of the matrix A and B. So A11, yeah, this is for matrix A, this will be your A11 and this will be our for matrix B, B11. So A11 is 2, B11 is also 2 plus A22, nothing but second row, second column, yeah, it is this second row, second column, this will be A22 and B22, nothing but second row, second column, yeah, this is a matrix for this matrix B22. So substitute here, A22 4, B22 is also 4, 2 2s are 4, 4 4s are 16, answer will be 20, 20, option B is correct. Let us suppose for the same problem we have got something like this. We want A31, B22, okay, 2 3, let us say. Okay, then how are you going to solve? Just from my end, because I think here you may think only diagonal elements are into consideration. So like this, let's take one more question. A31, third row, first column. Third row, first column, yeah, it is this. A31 and B23, second row, third column. Second row, third column, yeah, this will be B23. So A31, 1. Then B23 is 9. 1 into 9 is 9. Okay, this is extra, not a part of the problem. Okay, now let us move on to the next question. Question says, if A is a row matrix as well as a column matrix, then the order of matrix A is. See carefully. First recall, if I talk about any matrix A, the order is m by n. Now here they are saying it is a row matrix. For row matrix, number of rows should be 1. So m stands for row, so number of rows should be 1. They are saying it's also a column matrix. For a column matrix, number of columns should be also what? 1. So the order of the matrix A will be what? 1 cross 1. Option D is correct. Purely concept. Okay. Okay, dear students, think about the solution of this. This is 5. Think about the solution. What could be the solution? I know many will think option B, correct? But first recall the definition of diagonal matrix. It is a square matrix in which non-diagonal elements are 0. Or I can say for diagonal, other name is principal diagonal, okay? So when I say non-diagonal elements, you see carefully, these are the diagonal elements. But you can see this is non-diagonal elements. It's not equal to 0. Therefore, it's not a diagonal matrix. Now it is identity. For identity, diagonal element should be 1. Don't think none of this is the correct answer because it's a square matrix, because number of row and columns are what? 3 by 3, which obeys the definition of square matrix, which says number of rows and columns should be same. So option A is correct. Okay, option A is correct. Dear students, let us move on to next problem. Question number 7. A matrix A is a null matrix. We call what is the definition of null matrix? A matrix is said to be null or zero matrix if all the elements are zeros. Okay. Then what's the symbol of this? IFF means what? If and only if. Aij, nothing but the element of matrix A. For all I comma j, nothing but each and every element of A should be what? Since we know the definition for null matrix or zero matrix is what? Each and every element should be 0. So all the element of this, nothing but this matrix should be what? 0. Option A is correct, concept based. Now you see this. If this matrix is equal to this, then find the value of sum of this x, y, z and w sum. For this, surely we have to find all the values. Now see carefully. Equality of matrices concept. When do we say two matrices are equal? First, the order should be same. See the order? 2 rows, 2 columns. So 2 by 2 is the order. What's the order of this? 2 rows and 2 columns. Correct? No? 2 by 2. Since orders are same, I can equate the corresponding element. First element is equal to first. So we are going to have x minus y is equal to minus 1. Then you can see 2x minus y is equal to 0. Now either elimination method, substitution method, cross multiplication method, which or matrix method of this here, you can use whichever method you want. We can go for I think elimination method. So change the sign. Here it is plus, so I will change to minus. There is a minus, change to plus. Without any problem, y minus y will get cancelled. So I'll get what? X minus 2x will be minus x is equal to minus 1 plus 0 will be minus 1. Negative will get cancelled. X is equal to 1. Now let us substitute in equation number 1 to get what value? Y value. So if I put this in equation number 1, we have x is 1 minus y I have to find is equal to minus 1. Transpose on either side. 1 minus 1 become plus 1 is equal to y, or y is equal to plus 2. So we have got both the values of x and the values of y. Now let us move on to the other value. If I equate this to, see carefully what we are going to get. Let's solve it here. This is the options. Okay, so we are going to have 2x plus z is equal to 5. But what is x value? 1. Substitute here. 2 times of 1 plus z is equal to 5. 2 ones are 2 plus z is equal to 5. Transpose this. Z is equal to 5 minus 2, nothing but 3. I want last value is w. Okay, equate this element with the corresponding. It is 3z plus w is equal to 13. Z value is 3. So 3 times of 3 plus w is equal to 13. 3 3s are 9 plus w is equal to 13, or w is equal to 13 minus 9, or w is equal to 4. We want the value of this sum. Now let us try to find all the sum value here itself. See carefully. Now let us substitute here. What is the value of x? 1. What is the value of y? 2. Value of z we have got 3. Value of w we have got 4. So come on, add this. 4 plus 3, 5, 6, 7, 8, 9, 10. 10 will be the answer. So option C is correct. Okay. I hope this is clear. 4, 5, 6, 7, 8, 9, 10. Yeah. Now let us move on to this. I thought it may be required, so I just left the space. But anyway. Now let us proceed. Question says again, find the value of x. The difference between this problem and that, we had here linear system of equation, but here it's only one variable, but we have got degree to be more than 1. So again, the two matrices are equal. Orders are 2 by 2. I can equate the corresponding element. So when I equate this, we are going to have solution x square minus 4x is equal to minus 3. It's a quadratic equation. Transpose this, so we'll get x square minus 4x plus 3 is equal to 0. 3 ones are 3, so the factors can be, means I can write this 3, no? 1 into 3. How we are going to factorize a quadratic? X square multiplies 1. 1 into 3 is 3. So simplify this. 3 ones are 3. So if I write minus 3 minus 1, I'll get minus 4. I can get the middle term. So let us simplify. So here common is x. So remaining is x minus 3. Here nothing is common, so minus 1. Minus minus plus x here. Minus plus is minus 3 is equal to 0. So common is x minus 3. Then x minus 1, the remaining. Equate each one to 0. So I'll get x minus 3 equal to 0. X minus 1 is equal to 0. This will give x equal to 3 or x equal to 1. So one of the root we have got. See, 3 and 1 both are there in the option. We may think, what? More than one correct answer has come. Sabr, patience. You see, here we have different term compared to this. Wait and watch. There is a purpose of taking this problem. So anyway, we will highlight. We have got this solution. Next, equate this to x square equal to 1. When I equate x square equal to 1, take the square root on both the sides, get x equal to plus or minus 1. So I will take this as equation number 1, this as equation number 2. Next, equate this also. When I equate, what I will get? X square is equal to minus x plus 2. Transpose. X square plus x minus 2 is equal to 0. Again, 1 into 2 is what? 2. So I can write plus 2 minus 1 will give the middle term. So I write x square minus x plus 2x minus 2 is equal to 0. Common is here x, so x of x minus 1, here common is plus 2, so I'll get x minus 1, correct? So what is common here? X minus 1, and here the uncommon term is x plus 2. Now if I equate to 0, we will get from here x is equal to 1, and here I'll get x is equal to, this is plus 2, mind it, x equal to minus 2. So we have got this other set of values. This is minus 2. Now see the last one. X cube is equal to 1. If I simplify that, x cube is equal to 1. Take the cube on both the sides, you'll get x is equal to plus 1. Other root will be imaginary. Presently it is only real numbers. Now see carefully. For first one we got this 2 value. For the second, third, and all for each we got the values. Now here you should be extra careful. Don't think question is wrong, or don't think no it is more than one answer. No. First recall the definition of equality of two matrices. For it to be equal, order should be same. Yes, order is same. Corresponding element should be same. Mean to say, if I put x is equal to 3, no, both this matrix should be same. Surely when I put x is equal to 3, this 3 we have got from this equation, nothing but by equating this and this. Only this pair of element will be same. Remaining will not be same, because we didn't got the root for other same root as this. I hope this point is clear. Similarly, minus 2, if you substitute, okay, now see x equal to 3, put here 3 square is 9, 9 is not equal to 1. That's what I'm saying. 3 square is again 9, 9, and here this x is 3, no, minus 3 plus 2 will be minus 1. Minus 1 is not equal to 9. That's what I'm saying, that the value which is same for all, that is our x value. Only for that x value our matrices will be equal, which is that x value which is same for all the equation which we have equated. For this we got x equal to 1. This is same. You see this value. Again here we have two value, but in that x equal to 1 is the same common value. Here also x is equal to 1 common value, x equal to 1 common value. Therefore the correct answer is option B. Other set of values are not going to give the matrices to be equal. It will be unequal matrices. Okay, that's the motive of taking this problem. Make a note. Now let us move on to the next problem. The simplified form of, yes, surely I'm taking some trigonometric problems also, and it is surely there in matrices. Even if you have seen in PUC also, it is there. And surely I would like to take all the time, okay? And don't get panic, okay? At least from now, start learning those formula. I will quote the formula for this trigonometric identities, how to remember also. I'll again re-explain. Let us first start with the problem. So it's a scalar here, multiplying a matrix, scalar multiplication we know. Don't, as soon you see the matrices, don't change your concept. Okay, first recall your concept. If a matrix is multiplied by a scalar, this scalar should be multiplied to each and every term. First multiply that. So we are going to have tan into secant. Then tan into tan is tan square theta. Tan into tan is tan square theta. Plus into minus minus tan into secant theta. Then now I'll write it here. Okay, space not there. So plus secant into minus tan theta is minus secant theta into tan theta. Then plus into minus is minus tan into, okay, secant to secant is secant square theta. Again plus into minus minus, I think this is secant here, sorry. Secant to secant is what? Secant square theta. It is secant there, not secant square here. Secant it is. Plus into plus plus. Okay. So here we are having secant theta into tan theta. Now let us proceed. Now we have addition. How to add two trigonometric, means how to add two matrices, corresponding element. Now see when I add, see carefully when I add these two. Both are same but signs are opposite, so 0. Here it is tan square plus into minus minus secant square. So tan square theta minus secant square theta. I hope this is clear. Let us start from here. Now Again, this two element I have to add, or what you will get, tan square theta plus into minus secant square theta, then minus tan secant theta and plus secant tan theta, both will get cancelled, 0. Now trigonometric identity will be used. As you can see from the option, there are no trigonometric. So recall trigonometric identities. Which are those? First one is sin square theta plus cos square theta is equal to 1. I would like to suggest, keep 1 or 2 or let's say 3 pages empty. As of now, we are giving some new points, some formula which you have forgotten. Try to write down, okay, in 1 3 to 4 page you leave at the beginning and write down, so that you know for this chapter these are the things I have to learn. Okay, next, secant square theta minus tan square theta is equal to 1. Third one is cosecant square theta minus cot square theta is equal to 1. I know first one no one have it out. Second and third is a problem to remember for many students. Let us give an easy logic to remember. Simple. You see careful this two. What are the common things? First you see, both are difference of term. Both have got square and equal to 1. Correct? No. Common is what? Both are difference of terms. Both have got square equal to 1. So in English alphabet, which will come first in A to Z? First will come S, then will come T. Correct? No. So square minus equal to 1. You get the second one. Okay. Now how to go for third one? Very simple. Write CO before them. But be careful, write CO before them. Be careful that it is cosecant, not cos. Cos already used. So cosecant square minus cos square also got. Simple. Now come here. When I go with this formula, if you see very carefully, secant square multiple is positive, tan square multiple is negative. So if I take minus common from here, I will get minus to minus plus secant square theta minus to plus minus tan square theta. Same thing will happen for this also. Take minus common. Minus to minus is plus. So secant square theta minus to plus is minus tan square theta. So we are going to have 0 here. Then minus. This secant square minus tan square value is what? 1. Again minus here. Secant square minus tan square value is what? 1. Then here 0. So this is the answer. So this is matching with which option? Option B. So option B is correct. I hope this is clear. Okay, kindly make a note of this. Okay, dear students, let us again revisit to commutative. As we know, under multiplication, commutative is not true in general, but under what some special cases it is true. Let us try to discuss that. So first, if I say commutative, if I say in the question, if they mentioned under multiplication it is commutative, it means what? A into B is equal to B into A, if mentioned. I'm writing very clearly, if mentioned in the question. If mentioned in the question, you are not directly going to say it's always commutative. Already we discussed in PUC class. Second, let us suppose if they say anti-commutative. Anti-commutative. What is the meaning of anti-commutative? Two matrices are said to be anti-commutative if A into B is equal to minus of BA. Nothing but both are same, but there will be a sign difference there. Okay. So if at all this should be equal, this negative should be multiplied to each and every element of BA, matrix BA. Now some important things to be understood from here. See carefully. If I give you A plus B the whole square, all are matrices here. All A and B are matrices. Actually, the meaning of this is what? Recall what is A square multiplying A 2 times. Matrices multiplying A 2 times. Matrix A multiplying 2 times. Correct? No, so here it will be A plus B into A plus B. So now multiply them. A into A square. A into B, AB with plus sign. Then plus B into A. Then plus B into B is B square. This is the answer for A plus B the whole square. Now many students will think, sir, but we have learned in school days A plus B the whole square is A square plus 2AB plus B square. Why it is not obeying, sir? Understand here, when you are multiplying this twice, actually you are getting for this what? A square plus AB plus BA plus B square. Actually, since A into B and B into A are same, it's commutative. So AB plus BA is 2AB. So this is coming because in real number system, every real number is commutative in nature. A into B same as B into A. So it means that first of all, if at all in the question of matrices we have got A plus B whole square, it means on expanding we are going to get this. But let us suppose that in the question, if it is mentioned, that A and B is commutative, if A and B are commutative, only then AB is equal to BA. Only then this equation number 1 will change to A plus B the whole square is equal to A square. Since AB and BA both are same, so AB plus AB will be 2 times of AB because of this condition plus B square. So we are, whenever we see this type of thing is mentioned, it is understood that it is taken into consideration that A and B are commutative. Similarly, if I have been given A minus B whole square, which is same as A minus B into A minus B, on multiplication, we will get A square minus AB minus BA and plus B square. If it is commutative, AB is equal to BA, only then that will reduce to this. Since both are same because of commutative mentioned in the question, only then we will write. Understand this. When we are able to write like this, if it is commutative, again we are able to write school this formula if it is commutative. Similarly, one more point. What is A square minus B square? Okay, than this I would like to go like this. What is A plus B into A minus B? Yeah, this will be better. So from school, first multiply this A into A square. A into minus B, minus AB. B into A plus BA. Plus into minus, minus B into B square. Now, this is the expansion for A plus B into A minus B. But if I say that it is commutative, AB is equal to BA, only then, since these two are same but signs are opposite, it will get cancelled, and we are going to have A plus B into A minus B is equal to what? A square minus B square. So what I want you to understand and remember, my dear student, if you are getting our school days expression like this, like this, like this, you should click that. It's only going to happen if A and B are commutative. You should click. Okay, kindly make a note of this. Okay, dear students, let us move on next question number 11. If A is and B is given, A plus B whole square is A square plus B square, then A plus B value. That's what I was discussing. As soon as you see A plus B whole square, don't write this one as A square plus B square plus 2AB. No. In the question, they have nowhere mentioned it is commutative, and we know under multiplication of matrices, commutative did not be true. So this one we are going to write as A square plus AB plus BA plus B square, that's it, is equal to A square plus B square. Then we have to find A plus B, A values here and B values here. First, on either side, if you see very carefully, A square matrices and B square matrices will get cancelled. So remaining will be what? It will be AB plus BA is equal to 0 matrix. Cross transpose. So AB is equal to minus BA, nothing but it is anti-commutative. So now let us multiply A matrix is here. A 1 B minus 1, matrix B 1 minus 1 2 minus 1. Double check when you are substituting. Again 1 minus 1 2 minus 1, just a substitution. You are not going to multiply all and waste your time. No, you want A and B value. So you are going to only multiply that row and that column where A and B values we can get. Now for example, first have I copied the question correctly? Yes, done. Now see carefully. If I multiply this row, this column, yes, I can get A value, A part. Okay, A into 1 is A, then 1 into 2 is 2. Similarly, on the other side, try to get A. So if I multiply row and column, okay, I'm getting here. So 1 into A is A, right? Row versus column. Minus 1 into B is minus B. Fine. Next, let us, if I multiply this row and again the same column, see this is second row, first column, nothing but here the entry. So B into 1, B, minus 1 into 2, minus 2. Enough. Same, see, since I have got this value, I want the same corresponding value here. Again here, row versus column. 2 into A, 2A. Minus 1 into B, minus B. Enough. Don't fill the remaining. Whatever we want, only that we are going to solve. Okay. Now see carefully. Since they are equal matrices, I can equate the corresponding element. But when I equate the corresponding element, this minus should be multiplied in. So when I equate this, A plus 2 is equal to minus of A minus B, first part. Similarly, this and this, no. B minus 2 is equal to minus of 2A minus B. Now to simplify, A plus 2, here minus A plus B, equal sign. Okay, 2 here. So if I transpose here, I'll get 2A minus B is equal to minus 2. Just have taken all the term to the left and 2 is at the right. Now here also, if I transpose this entire thing, before that you see, minus 2A, minus 2 minus is plus B, B minus 2. Oh, B and B got cancelled. So here minus 2 is equal to minus 2A. 2 ones are 2 ones are. So negative will get cancelled. So A is equal to 1. Put in equation number 1. If I put in equation number 1, see carefully. 2 times of A is 1 minus B is equal to minus 2. Correct now? Now 2 ones are 2 minus B is equal to minus 2. Transpose both the term. So we'll get 2 plus 2 is equal to B, or B is equal to 4. And we have already got A value to be what? 1. So find the sum A plus B. What is A plus B? It is 1 plus 4 is equal to 5. Sum value of A and B is 5. Option D is correct. Okay. So I hope this point is clear. The main reason to take this problem was this point to be highlighted, that as soon as you see A plus B whole square, you will not write the school days formula, because under matrix multiplication, commutative did not be true. Now come to this problem. I have taken this problem to find X, as I have noticed many times students struggle with rectangular matrix. I have taken a combination of rectangle and square matrix here. We have to find the value of X. Listen carefully. Before you go ahead, now first go with the order. What's the order of this matrix? 1 row and we have 3 columns. So this is 3 by 1. Sorry, 1 by 3 I mean to say. 1 by 3. And this is 3 rows, 3 columns. So 3 by 3. And you have first row, second row, third row, and only 1 column. I am repeatedly saying before watching this, PUC part of the matrices should be done. Okay, you can think of watching in 1.5 speed. At least the concept which is there. Okay, in that. Okay, first 3 videos. 4 and 5th is what? 4 marker and 5 marker. Okay. Now, see carefully. First, see whether to multiply this 2 or this 2. Associative is true in matrix multiplication. So, whether you multiply this 2 first or this 2 first and then multiply with the other, no problem, because associative property A into B into C, whether if you multiply like this or if you multiply AB first and then C, no problem. So, let's multiply this 2. So, how to multiply? Row versus column. Since this number of column and rows are same, the obtained matrix order should be 1 by 3. So let us start with that, 1 by 3. So this will give a hint also how to proceed. 1 row and 3 columns will be there. So 1 into 1, 1. X into 4 plus 4x. 1 into 3, 3. As soon we multiply first row with the first column, when you go for the new column, we have to give a space. Now again, 1 into 2 is 2. X into 5 is 5x. 1 into 2 is 2. Okay. Now move on to the third column. 1 into 3 is 3. Then x into 6 will be 6x. Then 1 into 5 is 5. Just check have we did everything perfectly. 1 x4 fine, then 2 4x, then yes. Now don't forget this matrix is pending, so it is 1 2 3 equal to 0. Okay, matrix. Now see the order, 1 row and 3 column. Yes, 1 row 3 column, and this is having 3 row 1 column, so the number of column and rows are same. After I multiply, I'll get 1 by 1 matrix. Now again, how to multiply? Row versus column. This column I have to multiply. 1 plus 4x plus 3 into 1 will be the same term. Then this, before we multiply, I think before we multiply, let us simplify first. Simplify 4x. What is 3 plus 1? 4, no? And here 5x. How much? 2 plus 2? 4, no? And again 6x. 3 plus 5 will be 8. Then 1, 2, 3. Now multiply row versus column. Row versus column. Now, aram se will go. 4x plus 1 into 1 will be 4x plus 4 itself. Then 5x plus 4 into 2. Let us go step by step. 5x plus 4 into 2. Okay. Next, 6x plus 8 into 3. 6x plus 8 into 3. This is the matrix. Now simplify. There is no problem here. 4x. Okay, let's multiply here. 2 5s are. Let us multiply there itself. 2 5s are 10x. Then 2 4s are 8. Then 3 into 6 is 18x. Then 8, 16, 24. Is multiplication done correct? Yes. Now simplify here itself. Add like term, subtract depending on sign, same or different. What is 4x plus 10x? It will be 14x, right? Then what is 14x plus 18x? 32. So 32x. Then 4 plus 8 will be 12 plus 24. What's the value? 36. So plus 36 is equal to 0. Now find the x value. I can write this 0 matrix as this 0, nothing but 1 by 1, because the order is 1 by 1. Now this is of the same order. I can equate this. Sir, how you came to know the order is 1 by 1? Just by seeing this. And how I can write this 1 by 1? Because of the concept that if two matrices are equal, order should be the same. Since the order of this is 1 by 1, the 0 matrix we denote it denoted by capital letter O. So it is now 0 of order 1 by 1. Okay, as per the concept. So 32x plus 36 is equal to 0. Solve for x. 32x is equal to minus 36, or x is equal to minus 36 by 32. Simplify. 4 table. 4 9s are 36, 4 8s are 32. So I will get minus, okay, this implies x value is minus 9 by 8. Minus 9 by 8. See the option minus 9 by 8. Option C is correct. Okay. Now slowly we are building up our level. Okay. Make a note of this, dear students. Okay. Let us move on to next problem, dear students. Here we have got P and Q given, and here the entries are imaginary. Here we have to, they have to mention that where I is a complex number, I equal to root of minus 1. So complex number chapter, okay, where. Now, no need to multiply all and then get the answer. And again, it's not a shortcut, it's a concept, okay. Now see carefully all the entries, which entry is different compared to all. Before that, What is the order of this? 3 by 3. And what's the order of this? 3 by 2. So matrix multiplication exists. And when I multiply the matrix, the obtained matrix order will be 3 by 2. 3 by 2. Correct now? Number of row of the first matrix, number of column of the second matrix will be the obtained matrix order after multiplication. So whichever matrix order is not 3 by 2, first that is out. So this is 2 by 2. So out. This is 3 by 3. This also out. These two are what? 3 by 2. Now only the concentration on these two. And if you see, these two entries are different. And what's the location of that? First row, first column. So multiply only first row, first column. Plus into minus, minus. I into I square. 0 into 0 plus 0. Minus I into I will be minus I square. What is minus I square minus I square? Minus 2I square. We know that I square value is minus 1 from complex number chapter. So the value will be minus 2 times of minus 1, nothing but plus 2. Plus 2 is there in option B. Option B is correct. I know some students will be thinking, sir, that is usual way, the first row, first column. If I take some other element, sir, come on, think some other element. For example, let us suppose this. These two are different, correct? No. So this, actually all are different only in this. Yeah. Let us suppose this element you want. What's the location of this element? Okay. Second row and second column, right? A2, 2. So multiply second row, second column. 0 into I is 0. Minus I into 0 is 0. I into minus I will be minus I square. So that entry somewhere here, minus I square is minus 1. Minus to minus 1 is what? Plus 1. So that value should be plus 1. Yeah, plus 1. So what I'm trying to say is you can take any of the entries and then multiply and try to match. But I am saying that always try to take different. Why, sir? Let us suppose, no, this was also minus 2. For example, okay, this is plus 2. Okay, for example, plus 2 plus 2. Now, if I go for first row and first column, even if I get answer 2, no use, because again I have to do one more computation. So I have to make sure, let us try to go for least computation, because I have to complete the problem and move to the next question. In CET, for 60 questions, you have got 70 minutes. Don't forget. Okay. Now come to this problem. Okay. If A square is equal to A, then now this is purely concept based. A plus I whole power 4 minus 16A is equal to, and options are given here. Now this one, I can think of expanding like this. 4 is same as 2 2s are 4, minus 16 as it is, A as it is. Now this will form A plus B whole square. Sir, you are applying the A plus B whole square formula directly, but you said commutative did not be true. Listen carefully. When I multiply, I'll get A into I. Don't forget, A into I same as I into A. It is identity element. So matrix multiplication, we had a property itself. So this will be A square plus I square plus 2 times of A into I. Then the whole square as it is minus 16A. But in the question they have said A square is A itself. In place of A square, A plus I square. What is I power n? Whenever you multiply I any number of time, you get back the identity matrix I itself. So I, then plus 2 times of A into I into A, both are equal to what? A itself. So this will be what? A whole power 2 minus 16A. Then what is A plus 2A? It will be 3A plus I the whole square minus 16A. Again, this by using which formula? A plus B whole square formula. See carefully. This entire term is A. This entire term is B. So A plus B the whole square. So we are going to have 3A the whole square plus 2 times of 3A into I plus I square minus 16A. 3, okay, capital A here. Capital A here. 3 square is 9 scalar, then A square plus 2 into 3 is 6, a into I. What is a into I or I into a? Both are a itself. So this value when I multiply this 2, I'll get a. Then I square, I power n is always I. So I square is again what? I minus 16a. Okay, fine. So what is again a square? What is a square from equation number 1? A itself. So 9a, a square is a itself. 16a minus 16a. I repeat, 6a minus 16a is minus 10a plus I. What is 9a minus 10a? It will be minus a plus I. Minus a plus I is there in option A. So option A is correct. Okay, kindly make a note of this. Yeah, before going to next problem, I just thought maybe students will be getting confusion between this and this. Be careful. Here A sign is positive and here I sign is negative. Here we got A sign to be negative and I sign to be positive, which is same as what? I minus A. Okay. Okay. Dear students, let us move on to the next problem. Question says, if A and B are this matrices given, then only A into B defined, B into defined, both are defined, none of this. Nothing but matrix multiplication. No need to multiply, just check the condition. See, first for A into B to be defined, what is the order of matrix A? Here we have 2 rows, okay, and here we have 1, 2, 3, 3 columns. Coming to matrix B, we have how many rows? 1, 2, 3, 3 rows. And how many columns? 1 and 2, 2 columns. So multiplication to exist, this number of column of the first matrix, number of row of the second matrix should be same. Yeah, it is same. So A into B is defined. B, don't be in hurry. Here also you can see both A and B are defined. So check for B into A. B and A. B3 cross 2 is the order. What is all of A? 2 cross 3. As you can see, yeah, number of column of the first matrix and number of row of the second matrix both are same. Even this is also what? Multiplication of these two also defined. Both are defined. So option C is correct. No need to multiply. Concept. Now come to this. If product of two matrices are 0, then is it necessary that any one should be 0 or both should be 0? It's not necessary that both A and B should be 0. Already in our PUC class, I have discussed that product of two matrices is 0 doesn't mean that the element should be also 0. Okay, for example, if I take this is matrix A, this is matrix B. Okay, this is matrix A, this is matrix B. Now multiply them, both are non-zero matrix. Multiplying, how you multiplying? Row versus column. First row, first column. 1 into 0, 0. And 0 into 0, 0. Or 1 into 2 is 0. So we'll do one thing. We'll take 2 here. We'll take 2 here. Now see. This is gone. Okay, 1 into 0, 0. 0 2s are 0. Fine. Then 0 into 0, 0. 0 into 0, 0. Yes. 0 into 0, 0. 0 into 2 is 0. Okay. And here if you see both matrices A as well as B need not be 0. That's what it's saying. This all means either A or B or both also can be non-zero. Same like union. A union B means what? Either present in A or B or both. Okay. Now come to this problem. Find x plus y if this is satisfying. Okay, let's simplify this. 3 is a scalar. Matrix should be multiplied for this. So now see, don't multiply for all. I want x plus y. Just see where x is present. X is present here. Nothing but this and 3 I want. Correct? So 3 4s are 12. Then minus into minus plus. 2 2s are 4. Okay. Plus 4. Okay. Then 1 into x is x. If you are still more perfect, no, what we can know directly when I'm writing, no, there is no need to write 3 matrices. You know, all these are first element, first element, first element. Addition and subtraction also corresponding element. So 3 4s are 12. Then minus to minus plus. 2 2s are 4. Then plus into plus is plus x. That's it. I can skip this step. Now you see where is y? Y is present here. Which location? A2, second row, second column, nothing but I should write it here in this location. Some matrix B22. Okay. So now see 3 into 3, 9. Next minus 2 into 2, minus 4. Then plus into plus plus y is equal to 0 matrix. 0 matrix order will be 2 by 2 itself because we have got 2 by 2 in the left hand side. How can I say? See this? This is 2 by 2. This is also 2 by 2. This also what? 2 by 2. We know from the concept that if you add, subtract and go for scalar multiplication, order of the matrix will not change. So 2 by 2 only for this order. Therefore 2 by 2. Now equate. I have to equate this with this. Before I equate, 12 plus 4 will be 16 plus x is equal to 0. And 9 minus 4 is 5 plus y equal to what? 0. Now from here x is equal to minus 16 and y is equal to minus 5. So they want x plus y value. So add them. X plus y is equal to minus 16 minus 5 is minus 21. So minus 21 will be the answer. Kindly make a note of this. Dear students, I just forgot to give the options. Okay, so minus 21, option D is correct. Okay, make a note. Okay, yes, dear students, we are ready for the next problem. Question number 18. If A is if A is equal to this matrix is a square root of 2 road unit matrix, then alpha, beta, gamma should satisfy the relation. The relations are given here. They are saying this matrix, okay, A is means equal square root of 2 road unit matrix. Unit matrix means identity, it's a square root. Now I have to first remove the square root. So they say, see, A is square root of unit 2 road unit matrix, nothing but order is 2 by 2. Now if I square on both the sides, on squaring both the sides, I will get A square equal to I. By going with this condition, we have to get the relation. A square has been the multiplying matrices twice, so let's write A here. Alpha, beta, gamma minus alpha into again alpha, beta, gamma minus alpha. Don't forget A square means what? A into A. Then is equal to 2 road identity matrix. Now start multiplying row versus column. Alpha into alpha, alpha square. Then beta into gamma. Enough. Don't multiply the entire matrices. Sufficient. Is equal to first NP 1. So equate corresponding element. So when I equate corresponding element, alpha square plus beta into gamma is equal to 1. Is it recording? Yes. Always doubt. Now, see, right hand side is 0. So if I just transpose this term here, we get alpha square plus beta into gamma minus 1 is equal to 0. But option A not, because minus 1 we have. Coming to this, okay. So this is also gone, this is also gone because alpha square beta gamma are positive. Only this option is pending. So multiply toward by minus 1. If I multiply by minus 1 on both the sides, we are going to have minus alpha square minus beta into gamma plus 1 is equal to 0. That is very clearly matching with this. Yes. Minus alpha square minus beta gamma. Yes. Then 1 and 1 is equal to 0. Option B is correct. Now come to this problem. Question says if A is equal to this matrix, B is given, then A square is equal to B. Then for what value of alpha it is equal. Now again, as we know, A square means multiplying A twice. So I can just write alpha 0, 1, 1. Again alpha 0, 1, 1 is equal to the matrix B. Now multiply row versus column as usual. Alpha into alpha, alpha square, 0 into 1, 0. Now be careful. Now be careful. See, usually I say whichever we want, only that you can multiple get the answer. But in this options, no. See, there is no case like this. No alpha. This is a warning bell. It means that we had one problem, no? When we got the value of x to be 1, -1 and one more number. Only one was satisfying for 1 or -1. Any one was satisfying. Then only then that value we took. Because only for that particular x value, the two matrices were equal. So as soon we have got no, we have to cross check. We have to be extra precautioned. Similarly, none of this. Always we have to complete the problem. Now see this carefully. So alpha, now multiply to the first row to the second column. Alpha into 0 is 0, 1 into 0, 0 into 1 is 0. Okay, no problem. Then here 1 into alpha is alpha, 1 into 1 is 1. Okay, and here if I multiply, no use because there is no alpha in this case, so I can leave as it is. Now alpha square plus 0 is alpha square. Equate this. Alpha square is equal to 1, nothing but alpha equal to plus or minus 1. Plus or minus 1. Now equate this to alpha plus 1 is equal to 5. Alpha is equal to 5 minus 1, nothing but alpha equal to 4. Now if you see 4 is there, minus 1 is there, 1. Many students will think it's a multiple choice question. No, my dear students. It's not just because of CET, it's wrong. No, no, no. Even if JE or even if it is no multiple correct answer problem, if this question is given, see carefully, alpha is equal to 1. If you substitute in a square, nothing but this. Okay, a square, no. So here if you multiply, you get 1 into 0. Okay, see this. Now for this, if you substitute in this matrix, let I repeat, in this matrix, if we are going to substitute this alpha value, you will see that it will not give this matrix. For example, I will take this as equation number 1. Put alpha equal to 1 in 1. What will happen? 1 square is 1. 1 plus 1 is 0. 1 plus 0 is 1. Then 0. 1 plus 1 is what? 2 and 1. See this. 2 is not equal to 5. Similarly, put alpha equal to minus 1. Minus 1 whole square is 1. This will always satisfy because this value we have got after equating alpha square is equal to 1. But you see this. Put alpha is equal to minus 1. Minus 1 plus 1 will be what? 0. If I put alpha is equal to minus 1 here, I will get alpha plus 1 nothing but minus 1 plus 1 nothing but 0. But we wanted 5. Similarly, put alpha is equal to 4 here. What we will get? If I put alpha is equal to 4, we will get here alpha square nothing but 16. But in the problem, we have got 1. I hope this point is clear. And one more thing, again I repeat, why is this alpha equal to plus or minus 1 is satisfying this? Because we have equated this to this element, only then we have got. Surely it will satisfy. You have to actually check the other. I have shown all the steps here for your clarity. Okay. So for this, no value of alpha will make this matrices equal. Let I put in tick in black color. Okay. Make a note of this. Okay. Dear students, let us move on to next problem. Question says, x and y are 2 by 2 matrices such that 2x plus 3y is equal to 0 and x plus 2y is equal to identity matrix. Here it is 0 matrix and here it is identity matrix. That's what they have said, and it's 2 by 2. So they have already specified. Actually speaking, no. If they could have not given this line, no, that O and I stands for 2 by 2 matrices, then also fine, because already x and y are 2 by 2. From the concept we know, if you have a scalar multiple, order will remain same, and when you add or subtract, order will remain same. So the addition, since this is 2 by 2, this is 2 by 2, addition also 2 by 2, scalar multiple also 2 by 2, therefore it's equal to this, so it's also again what? 2 by 2. So this part need not be given. Okay, solution. Then we have to find x value. Let's take that. 2x plus 3y is equal to 0, and here x plus 2y is equal to identity. Target is on x, not on y. So you can think this as two equation, system of linear equation in two variables. So here I want x, don't want y. So what we used to do, elimination method, substitution method, cross multiplication method, whichever you want. Now let's suppose we go for elimination method. Since I want x, I should remove what? Y. So how to remove y? Multiple should be same. So what I will do, this is my equation number 1, equation number 2. Multiple of y is 2. So multiply here and multiply y is here 3, multiply here, so that multiple of y will be same in both the equation. 2 2s are 4x plus 3 into 2 6. 0 matrix into 2 will be again 0, because when you multiply each and every element to 0, means each and every element 2, I repeat, each and every element of this matrix is 0. When you multiply by 2, you will get 0 only. Then 3 into x is 3x. Then 3 into 2 is 6. Then 3i. Now change the sign. So simple, we can get the answer. This is gone. 4x minus 3x is plus x. 0 minus 3i will be minus 3i. Now it is formed in the matrix. So what is I? 1 0 0 1. Multiply minus 3 in. What you will get? Minus 3 into 1 is minus 3. Minus 3 into 0 is 0. Minus 3 into 0 is 0. Minus 3 into 1 is minus 3. So x is equal to this matrix, which is there in option C. And it's also that whenever you multiply identity matrix by a scalar, the output is what? Scalar matrix, that we discussed in PUC concept. Moving on, next problem, question number 21. If A is given as 1, 2, 3, then the value of A into A transpose, where A transpose, this symbol A dash stands for the transpose of the matrix. That's understood. Okay. Anyway, A into A transpose. Again, I'm taking rectangular matrix also. What is A? 1, 2, 3. What is A transpose? Change the row to column, so the row matrix will become a column matrix. Now, what is the order of this? 1 cross 3. 1 row, 3 column, and this is 3 cross 1. So if I multiply, since number of column and number of rows of the second matrix, number of column of the first matrix and number of row of the second matrix are equal, matrix multiplication exists. When I multiply, I should get 1 by 1. See the option where we have 1 by 1 order. Yeah, only here. So only option B is correct. It's not shortcut. It's a concept. Shortcut also required. Concept also required. Okay. Now, no sir, I want to multiply and get the answer. No problem. All we have got the answer. Just for let us have better idea. Let us have a practice of multiplication. 1 1s are 1 plus 2 2s are 4 plus 3 3s are 9. What's the answer? 14. That's what we got. Okay. Make a note of this. Okay. Yes, dear students. Let us move on to the next question. Question says, if A transpose is this matrix and B is given, then find A transpose minus B transpose. Be careful here. A transpose is given, but B is given, but I want B transpose. So when we are going to solve A transpose minus B transpose, what is A transpose? Direct substitution, nothing else. Okay, then B transpose, change the row to column. So this first row will change to first column. This second row will change to second column. No, be careful. It should not happen. No, you didn't notice and you think that orders are different and question is wrong. Okay, fine. Now just observe the element. So here from this one thing is clear, that when I'm going to add, since the order is 2 by 3 for both the matrices, subtraction of this also will give 2 by 3. 2 by 3 is not in this option, gone. Remaining we have to check. Now we can just see any element which is different. Okay, let us add this. First element you can see here, no? Minus minus plus. So I get 3 plus 1, nothing but 4. Yeah, 4 is there here. Option C is correct. Okay, I just wanted to have a note for you people that let us suppose the question was like this, that you have to find A minus B. So same question is A minus B. Then B is already given, but here we have A transpose. Don't forget, if you take transpose 2 times, you get back matrix A only. So for this again, if I take the transpose, I will get this first row will change to first column, that is 3 4, and second row will change to second column, third row will change to third column, and then you can perform the subtraction. Okay, fine. Now come to this problem. Question number 23 says, if A is this matrix, is a matrix satisfying A into A transposes 9 times of identity with order 3, then find the values of A and B. See, this I3 need not be mentioned because we know that since it's a square matrix, whatever the product I get, the same order I should be there. Correct? Now, whatever the left hand side order is the same order, and it's 3 by 3 only because A is a square matrix. And we know that if you take transpose, How do you transpose? Convert it row to column and column to rows. So square matrix order will remain same. Now see, A into solution, A into A transpose is 9 times of I. A is given here. See carefully. 1, 2, 2, 2, 1, minus 2, A to B. Now I want transpose. For transpose, change this row to column. So this first row will become first column. Again, this second row will become second column. And this third row will become third column. Is equal to 9 times of 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, no? Now you are not going to multiply each and every term. Okay, this is A. You are not going to multiply each and every term. No, just see. You want A and B. Just find that position, location, the row and column where A and B are present. So A is present in the third row. And if I multiply with this, I will get one equation. Okay. Now be careful. This is third row and first column. So when I multiply, I should write here third row, first column into A, 3, 1. So this is index, okay. A into 1 will be A, 2 into 2 will be plus 4, then plus 2 into B will be plus 2B. Okay. Next, I want one more equation. Again, retaining this, if I multiply with the second column, so a third row and second column, so nothing but here, third row and second column. So see, A into 2 will be 2A, 2 into 1 will be plus 2, B into minus 2 will be minus 2B, and entries. We are least bothered about the remaining. Now see, I am only focusing on third row first column and third row second column, nothing but this. 9 into 0 will be 0 for both. So I have to just equal to 0. So now, just see this carefully now. A plus 2B plus 4, nothing but this is equated to this element equal to 0, and this also equated here. So we are having here, then 2A here, then minus 2B plus 2 is equal to 0. Now elimination method we can apply. 2B minus 2B will get cancelled. We'll get A plus 2A will be 3A. 4 plus 2 will be 6 is equal to 0. Or 3A is equal to minus 6. Or A is equal to minus 2. Because 3 ones are 3 2s are. This is 2. Mind it. This. Okay, fine. Continue. So from here, I can take this as equation number 1. So if I put in equation number 1, we have A plus 2B plus 4 is equal to 0. A value minus 2. So minus 2 plus 2B plus 4 is equal to 0. 2B minus 2 plus 4 is plus 2 is equal to 0. Transpose here. 2B is equal to minus 2 there. 2 and 2 will get cancelled. B is equal to minus 1. So A is equal to minus 2 and B is equal to minus 1. Which option is correct? A is equal to minus 2 and B is equal to minus 1. Option C is correct. Option C is correct. I want to quote one more thing here. You should be very careful with this. See, here you can see minus 1, minus 2 is also there. So in urgence, you may think of picking this. Be careful in each of the option. No. The first set of value is talking about A because A is first in the question. And second set of value is talking about B. It should not happen. No. You are confused which to take. You got A is equal to minus 2, B is equal to minus 1. So as per the order, first is A, next is B. So in all the options, first values of A, second of possible values of B. Okay. Be careful about this. Make a note. Okay. Dear students, let us move on next problem. Question says, if A and B is given, we have to find A into B the whole transpose. First find AB and then find the transpose. Again, I have taken a rectangular matrix. Okay. So A into B. So how to go about it? Again, we can also go through the options and then go ahead. But I thought this one, let I again do it because many students struggle with multiplication of matrix whenever it is rectangular. Nothing but number of rows and columns are different. So let I solve it usual way. 1 into, see, first row with first column. 1 into minus 1, minus 1. As soon as I go for the new column, I have to give a space. 1 into 2 is 2. Again, as soon as I finish this second column, go for third column. When I go for third column, again give a space. You have to multiply with the first row with all the columns, correct? 1 into 1, 1. Okay, now A into B the whole transpose, if you take -1 2 1, just match -1 2 1, it's there here also and here also. Anyway, option B and option C is out. Okay, now let's move on with this. -4 into minus will be +4, -4 into 2 will be -8, -4 into 1 will be -4. So again, if I take transpose, I'll get 4 -8 -4, 4 -8 -4. Yeah, 4, yes, it is matching with this. Option A is correct. Anyway, let us complete the problem. 3 into -1 is -3, 3 into 2 is 6, 3 into 1 is 3. Again, take transpose, -3, this row will change to column. Yeah, have we got? Exactly, yes. Option A is correct. Come to this. Again, trigonometry, yes, we have to, don't forget the entire thing is on calculus, on trigonometry only, no? In calculus part. If A is equal to cos theta, sin theta, minus sin theta and cos theta, and then A transpose plus A is equal to identity of order 2, then given one general solution type, let us just give as a note for you from trigonometry. As I said, no, you have to have 2 to 3 pages empty at the beginning, so that as I'm giving some note, you can write all together. Now here some notes. What if general solution we are talking about? If sin theta general solution, okay, I give here, we are talking about general solution. If sin x is equal to sin y, then x is equal to my power n. Okay, x is equal to n pi plus -1 power n into y. Second one, if cos x is equal to cos y, then the general solution of this will be x is equal to 2n pi plus or minus y. Third result, if tan x is equal to tan y, then the general solution of this will be x is equal to n pi plus y. In all the cases, n is what? Integer. Okay, where n is integer. So having this knowledge, let us proceed. So the solution, fine, of this. So A transpose plus A, find the transpose of this. When I take the transpose of this solution part, this is the first row, will become first column. Okay, now I have to solve completely. Then A is here. What is that? Cos theta minus sin theta is equal to identity. So for identity matrix, this is 1 0 0 1. Correct now? So now let us try to simplify. You see, sin theta minus sin theta will get cancelled, get 0. So anyway, I can equate with this. So cos plus cos will be 2 times of cos theta is equal to 1. Correct? No, I hope it's visible. It is 1 here. Okay. So now cos theta is equal to half. Which angle of cos will give half? Which angle? Cos 60. Nothing but cos pi by 3. Right? That you can see present here in the general solution. That's why I give this concept. Don't think as in none of this. Now see, if I go with this, let us highlight. It is going with this. Cos x is equal to cos phi. So in place of x we have theta. In place of y we have pi by 3. So the general solution will be x is equal to, so in place of x, theta. So theta is equal to 2n pi. Yeah, 2n pi plus or minus y. What is y? Pi by 3. Where n is what? Integer. But in the option they are given only one. See, 2n pi plus or minus pi by 3. So only one part of the solution is given. Okay, so option C is correct. Make a note of this. Okay. Dear students, let us move on to next problems. The matrix, okay, the matrix product satisfies this condition where A transpose, here you can see now, A transpose, A power T denotes transpose of the matrix A. Then the order of the matrix A is, okay, fine. See carefully. Solution. First, let us assume the order of the matrix A is m by n. Then this implies that if I take the transpose, we know number of rows and columns, that means rows will change to columns and columns will change to rows. So this order will be n by m. So now let us copy this 5, 6, 2. Then A transpose and order is n by m is equal to, then here 4, 8, 1, 7, 8. Now what is the order of this? We have 1 row and 3 columns, so 1 by 3. And what's the order of this? We have 1 row and 1, 2, 3, 4, 5 columns. And we want the order of A, okay? But we will get from here A transpose. Again, we have to take transpose of that. Now see carefully. Here matrix multiplication is defined, provided number of column of the first matrix is equal to number of row of the second matrix. So here 3 should be equal to n, or n should be equal to 3. Now after I multiply this, I get one matrix. And that order should be number of row of the first matrix and number of column of the second matrix. Nothing but 1 cross m it should be. And already here, this matrix NP, that is not right, only we want order. So yes, now for equality, order should be same. Yeah, 1 is equal to 1. So m should be equal to what? 5. So the order of A, which we have taken m by n. Now that will be order of matrix A is m is 5. What is n value? 3. So 5 cross 3. 5 cross 3 is there in option D. Okay. Now let us move on to the next problem. Question says, if A and B are square matrices of the same order, and if A is equal to A transpose, B is equal to B transpose, then we have to find what is the value of this expression. Now, in place of writing like this, they could have also said A and B are symmetric, because for symmetric, A transpose should be equal to A. Correct? Now, recall one important result. We know that if I have got A into B, and if I take transpose, it will be B transpose into A transpose. Nothing but the order of the matrix will change. This is first, this is second. Now second come first, then the matrix here. This we call reversal law. If I have got similarly A, B, C whole transpose, so see carefully, first matrix is A, second is B, third is C. But now it is going to reverse. So C transpose, B transpose and A transpose. So even for n number of matrices, same thing is going to happen. Now when I take the problem here, even if you want, you can go for general A1, A2, A3, like this, AN. If I take the transpose, then what will happen? First will be AN, like this, then A3 transpose, then A2 transpose, then A1 transpose. Okay? Fine. So for this, first, second, third. So this third matrix A will come first, then B remains in second, then this A matrix will be in the third. Okay? And for each it is transpose. Okay? But in the question they have said they are symmetric. So A transpose is A, B transpose is B, and again A transpose is A, because the data given here. So this is matching A, B, A, option B. Okay? Kindly make a note of this. Okay. Dear students, let us move on to symmetric and skew symmetric matrices. Already concept is given. Just there are some additional thing to be discussed. Let us take that and then we'll take up the problem. So now here we are with symmetric matrix. A square matrix A, as we know, is said to be symmetric matrix if A transpose is equal to A. And coming to skew symmetric matrix, a square matrix A is said to be skew symmetric if A transpose is minus A. Now, in this, some of the important note to be understood. First point. From PUC, we know that if I add the given matrix and its transpose, then it will be symmetric. Similarly, if, okay, second point here, if I subtract with its A and A transpose, I'll get skew symmetric. Okay. Now, next, if I multiply A and its A transpose, what type of matrix we can get? Let us try to understand here. B I will take it as, this one I'll take as B. Now if I take transpose on both the side, and I'm just saying A is a matrix. Okay, A is a matrix. Let us suppose here mention if A is any square matrix. I'm not saying A to be what? Symmetric matrix. It can be any square matrix. Now if I take transpose, just now we discussed the reverse law. So as per the order, who is first? A. Second is A transpose. So A transpose the whole transpose into A transpose. But A transpose the whole transpose, A itself, then A transpose. Recall the result that A transpose the whole transpose, what? A itself. So this is nothing but matrix B itself. Okay, very clearly we have got that. This is also symmetric. Similarly, if I change the order, A transpose into A, then also it is symmetric, provided A is any square matrix. Okay. Similarly, if I multiply a scalar, okay, for that it is should be a square matrix. So this all are what? Symmetric matrix. And this is, as you know, skew symmetric matrix. And let us recall that every square matrix can be expressed as sum of symmetric and skew symmetric. So A is equal to half of A plus A transpose, then half of A minus A transpose. So this part is symmetric, and this entire part is skew symmetric matrix. Okay, having this, now let us suppose that, note number 4, if I have got one matrix A and it is symmetric matrix, okay, if it is symmetric matrix, then always A power n, whatever A square, A cube, A power 5, A power 100, whatever we ask, is again symmetric matrix. Remember this important result, symmetric matrix. Fifth point, let us suppose if A is skew symmetric matrix. Skew symmetric. All this you should remember, make as a note. Now this one we can call as some short trick. Okay, if A is a skew symmetric matrix, then now listen carefully. Then what about A power n? We have two cases here. Then A power n will we have two scenarios. If this power n is E1, okay, then A power n is symmetric. Be careful, it is symmetric. It won't be skew symmetric. Symmetric matrix. If n is odd, then A power n is what? Skew symmetric matrix. And let you have this note that if you take transpose and then inverse is same as A inverse the whole transpose. We can extend transpose and inverse. Okay. So we have all this. So we whenever I can give some more results to memorize. How many you can memorize? So as in hope you'll get some problem. Surely we can use all the properties which we know and the logic of this definition which we know. Surely we can go ahead and recall. For skew symmetric matrix, diagonal elements are always 0. Even if one diagonal elements are not 0, then it's not a skew symmetric. In detail in PUC, I have discussed. You can have a look over there. Make a note of this. Okay, dear students, let us move on to the next problem. Question number 28. If the matrix A is symmetric matrix, then find the values of x, y, and t respectively. So I have taken a very basic problem. For symmetric matrix, recall definition is that A transpose equal to A. But I have also given one more concept that this is your principal diagonal elements, correct? Now the corresponding element with respect to this is going to act as a mirror. Okay, so here you can see the reflection type. So y value is 2, x value is 4, t value is -3. For symmetric matrix, this corresponding element, no, which are given arrow mark, should be same, nothing but aij should be equal to aji if at all a is equal to a transpose, correct? No, so from here very clearly y is equal to 2, x equal to 4, and t is equal to -3. X, y, z. So x is 4. So 4, 2, -3. 4, 2, -3 is then option B. Okay, that's it. Now let us move on to 29th question. If A and B are skew symmetric matrices, then 3A plus B is what? That's what I said, no? In place of memorizing so many, whatever I have given the content sufficient. Now you should analyze. See, in the question they have given A and B are symmetric matrices. So I can write A transpose is equal to -A and B transpose is equal to -B. We have used the data. Now we have to know what type of matrix is this. They are asking null, symmetric, skew symmetric, none of this. Whatever the matrix they have asked, take as 3. That one we can take as, that is matrix 3A plus B. We can take some matrix C. Whether it is symmetric or skew symmetric, transpose is mandatory. So take transpose on both the sides. After taking transpose on both the sides, recall some of the property. What? We know that A plus B the whole transpose is same as A transpose plus B transpose. Nothing but we can take transpose for both. And we also know that K, the scalar into matrix, if I take transpose will not affect the scalar. It's only for the matrix. So 3 will not be affected. Then A transpose, then plus B transpose. Now from here, A transpose is -A. So we will get -3A. B transpose is -B. Now, if I compare with what I have taken, or whatever I have assumed, whatever we have assumed, C, it is exact negative of that. So if I take minus common, we will get 3A minus plus B. So we will have minus this 3A plus B C. So C transpose, see we have got C transpose on the left hand side. C transpose equal to what? Minus C, which is a definition for skew symmetric matrix. So option C is correct. Similarly, if it is A and B given what? Symmetric matrix, it will be again symmetric matrix. Let us suppose A is given as symmetric matrix and B as skew symmetric matrix. Then A transpose will give you plus A. B transpose will give you minus B. Then it will be none of this. Okay, because it is neither symmetric nor skew symmetric. Surely it need not be null. Okay, now come to this question number 30. If A is a symmetric matrix, then what is the A transpose, the whole transpose value? See, whether this is given or not, recall the property. What is A transpose, the whole transpose? A over. Okay, simply this statement is given by the property, we know that. Okay, now similarly for skew symmetric also. Let us suppose no, so I want to use this concept and then get the answer. I gave the answer directly from the property, but I want to use this and get the answer. Yes, we can. See, A transpose, the whole transpose. For symmetric, what happens? A transpose equal to A. So the term inside this transpose, this entire matrix A transpose will be what? A. Then this transpose as it is. Again, A transpose what? A itself. Both the ways we can get. Okay, but by property in one shot we can get. Next, question number 31. Okay, this is option A. Question number 31. If A is a skew symmetric matrix and n is any natural number such that A power n whole transpose is equal to lambda into A power n, write the values of lambda. I want to know the value of lambda. Just before taking the problem, I have discussed that if A is skew symmetric matrix, then what will be A power n, whether symmetric or skew symmetric. There I have discussed that if A is a skew symmetric matrix, A power n will have two roles. It can be skew symmetric. It can be skew symmetric matrix if n is odd, and it will be symmetric matrix if n is even. Now see carefully. Now here n they have just said natural number which comprises both odd as well as even natural number. So when I want to write the value of this solution, when I want to write the value of this, see carefully, a power n whole transpose. One property I want to quote here, listen carefully. As I said, have list of formula page, then in the result we can write the list of formulae. What? A power n whole transpose is same as A transpose whole power n. Nothing but transpose and power can be interchanged. So here it is A transpose whole power n. But since A is skew symmetric matrix, recall the definition for skew symmetric matrix. Is it not for skew symmetric matrix? A transpose is what? Minus A. So in place of A transpose minus A whole power n. I can write forever this as minus 1 into A power n. Can't I write this one as minus 1 whole power n into A power n? So in place of this lambda which we want to find, see in place of lambda what do we have? What do we have? Minus 1 power n. Minus 1 power n is there in option C. Option C is correct. And to be specific for you, here what have I did? I use law of exponents, correct? No? I use law of exponents. What it says, okay, I write it here only. I have used law of exponents. It says A into B whole power n is A power n into B power n. So minus 1 power n into A power n. Okay. So yes, all the problem completed. Make a note. Okay, dear students, let us move on to the next question. Now, since we are discussing symmetric, skew symmetric, so I have taken a problem on that. Question says, the matrix A given by this is a symmetric matrix, skew symmetric matrix, both A and B, none of this. See, for definition of skew symmetric matrix, we know A transpose is equal to minus A. From here itself, we can get one knowledge. What? See this carefully. General way of writing this element is this Aij. Minus sign is this minus, and this will be Aji. Correct? No, this will be what? Aji. For symmetric, plus is there here. A transpose is equal to plus here. So that's what, no? With respect to diagonal, corresponding element A12, A21 should be same there. But here, sign will be opposite. And to make it equal, this minus is multiplied. Now you see carefully. First, diagonal elements are 0, na? Yes. Let us suppose even if one of the diagonal elements are non-zero, there is not skew symmetric. Even if this condition holds also, it will not be symmetric, skew symmetric. It will not be skew symmetric if any one of the diagonal elements are non-zero. Now you see here 5 minus 5, minus 8 plus 8, minus 12 plus 12. So it's obeying this definition. Therefore, it is skew symmetric. No need to take transpose and all. Okay, just like this, you can get the answer in one shot. Okay, I said you. Trick also be given, but concept and trick both are important for us. Okay, write a 2 by 2 matrix which is both symmetric and skew symmetric matrix. See, need not be 2 by 2, it can be n cross n. Listen the logic here. I will give the logic for 2 by 2, same logic for n cross n. See, they want both it to be skew symmetric and symmetric. First, for skew symmetric, diagonal element should be 0. For symmetric, as we know, Aij should be equal to Aji. And for skew symmetric, Aij should be equal to minus Aji. I mean to say this is A transpose, A equal to A transpose, and this is A equal to minus A transpose. Okay. But now, if at all both should agree, here negative is there, here positive is there. The only digit where there is no problem for the digit to give plus 0, plus number or minus number, both are same. I mean to say, if this is 0 and here 0, first diagonal elements are 0, so it is what? one condition satisfied of skew symmetric. Now for skew symmetric, non-diagonal element, the corresponding element which is like this, sign should be opposite. So if I say this is sign is plus 0, this should be what? Minus 0. Skew symmetric condition satisfied. But for symmetric, the sign should be also same. That's what only 0 can do that. That whether you write plus 0 or minus 0, there is no problem. Due to which it is the only element which can obey this is 0. So all the corresponding element with respect to the what I can say diagonal should be always what 0 there. Therefore option C is correct. This is not only true for 2 by 2, it's for n cross n, that whenever I want to think of a matrix which is both symmetric and skew symmetric, it's always a null matrix. So option C is correct. Now let us move on to question number 34. If the matrix A is given, is skew symmetric matrix, then the value of A plus B. So for skew symmetric, first diagonal element should be 0. Yes, it is 0. Now corresponding element, you see A is there and here 2. So minus A should be equal to, I mean to say, let us write like this directly. A, since here 2 is there, A should be what? Minus 2. That also was right. What I just wrote, also I write only. Next, you see this. Since it is minus 3, B should be equal to plus 3. Whatever the sign is that opposite sign. You can see here. Minus 1 plus 1 opposite sign. Number should be same. Now I want A plus 2. Okay, A plus 2 value will be minus 2 plus 3, nothing but 1. Option B. Okay. Now this particular question has a 3 marker. First let us read the question. If A is given as this, is written as A is equal to P plus Q, where P is symmetric and Q is skew symmetric, then write the matrix P. This you have did in PUC for 3 marker question. Question was express the given matrix A as the sum of symmetric and skew symmetric, and you know the procedure. Now we are going to learn a technique where we can get the answer faster. First I will do for 2 by 2, then I will take next problem for 3 by 3. But here they ask only P, nothing but symmetric, but I will teach you both, because who knows, if they may ask anyone, no, or they may ask both also. So let us be benefited. So see carefully how to write. And the logic no is just in the formula only. See carefully. What was the formula of expressing a given matrix to be sum of symmetric and skew symmetric? A plus A transpose, then plus half of A minus A transpose. This was the logic. This was the formula. From here, just see. I am going to write the question. See carefully. For symmetric matrix, no, diagonal element written as it is 3, 9. Okay. This I am talking about symmetric matrix. Now what you have to do is the corresponding element, whichever is there, which is that 5 and 7. You see, you have to add, divide by 2. Formula itself is saying add and divide by 2. What is 5 plus 7 divided by 2? 5 plus 7 is how much? 12. 12 by 2 how much? 6. So this element is 6. And for symmetric matrix, this should be also what? 6. Symmetric but done. Okay, let us repeat again. When I do in this class, our class, no, soon be shocked what happened. So let us repeat again. For symmetric matrix, first retain the diagonal element 3 and 9 as it is of the given question. Then, as you can see, it is addition and divide by 2. So take that corresponding element 5 plus 7 by 2. Why by 2? Because of the formula. 5 plus 7 is 12. 12 by 2 is what? 6. So I wrote 6 here. Same thing I carry 6 here. Okay, because for symmetric matrix, whatever the element is here, same element should be present here also. Now we have already got the answer. 3669. 3669. 3669, option A is correct. But as I said, let us also complete skew symmetric, because who knows, they may ask for skew symmetric. For skew symmetric, what you will do is plus, again observe here, first diagonal element of skew symmetric should be 0. Correct? No, I wrote. Now you see here it was addition, now here it is subtraction. Now addition is no problem, subtraction no, lot of error will be done by the student. See carefully how to come and not do the errors. Now see carefully, right? Erase this arrow mark. Now you decide where to go. Means you want to subtract here and right or here and right, and then divide, subtract and divide by 2. Now see, let us suppose I want to write here. So see this. I'm just taking 7 here. So the element which is moving, see 7 is moving to 5. the element which is moving, that sign should be changed to minus. So see here, 5 remains as it is, so 5. 7 is moving, so minus 7 divided by 2. How much is 5 minus 7? Minus 2. Minus 2 by 2 will be minus 1. So this is minus 1. Since this is minus 1, what should be this plus 1? Okay, like this we cannot think of exchanging. Here you should be very careful. Okay, let me repeat again. What I said, the element which you want to move, its sign should be changed. So let us suppose that we wanted to write this element. So 7 should move. So sign of 7 should be moved because of this logic of minus. So 5 minus 7 divided by 2. 5 minus 7 is minus 2. Minus 2 by 2 will be minus 1. No, sir, I want to move below. Then see carefully the logic. See the logic here. Let us suppose that you want to move this side. Nothing but who is moving? 5 is moving, 7 is not moving. So sign of what? 5 should be changed from plus to minus and minus to plus. So see here, 7 is there. Okay, as it is. Now 5 is moving down, moving its place, so minus 5 divided by 2. 7 minus 5 is 2. What is 2 by 2? 1. That's what you can see. Here we wrote 1. Okay. The one who is moving, its sign should be changed. I repeat, the one who is moving, its sign should be changed. I'll take one more problem on 3 by 3 so that the thing should be clear. And you can see yourself, if you add this 3 plus 0, 3, 6 minus 1 is 5, 6 plus 1 is 7, 9 plus 0 is 9. Yes, we are getting the matrix. Don't use this in PU board exam. For 3 marks, you will get 0 marks. Okay? Make a note. Okay, dear students, having understood 2 by 2 matrices, how to express sum of symmetric and skew symmetric, let us go on to 3 cross 3. Okay, let us move on to 3 cross 3. Question says if this is a matrix, is a sum of symmetric matrix B and skew symmetric matrix C, then find B. But we'll find both. Okay. Now, see carefully. Coming to matrix A. Okay, I will write it here again, so that again it will be easy for us. See this. What is matrix A given in the question? 4, 2, minus 1. Then 3, 5, 7. Try to solve by that logic. Let us see how many can get before me and comment in the comment box. Okay. Now see. But no sitting, huh? Now see carefully. What I said? Diagonal element should be same for which matrix? Symmetric matrix. For symmetric matrix, diagonal element should be same. Which is the diagonal element? 4, 5, 1. So 4, 5, 1. Okay. Now next thing is 4, 5, 1. You can see here, as soon as we see the option B is correct. Okay, answer is done. But let us learn how to do it. Now see carefully. Okay. Now see carefully how to go about. So this is our diagonal element. Now here you have to add this corresponding element. 3 plus 2, 5, 5 by 2. Whatever you wrote here, same element here. Corresponding element should be written the same. Next, you see this 1 and minus 1. How much is minus 1 plus 1? 0. So as you wrote 0 here, you should write here also 0. Next, add this 2. 7 minus 2 is 5. 5 by 2. You have to divide by 2. Check. Have you got the same? Yes, same. Now let us also understand skew symmetric. For skew symmetric, diagonal elements are zeros. Now in place of adding, you should subtract. Now I said the one who is moving, its sign should be changed. So let us say that I am taking this 3 and moving to 2. Then what will happen? 2. Since 3 is moving, so 2 minus 3 is what? Minus 1. And we should divide by 2 also. So minus 1 by 2. So here minus 1 by 2. The corresponding element here will be plus 1 by 2. Because for skew symmetric, elements are same but sign should be opposite. Similarly, now just suppose again this 1 is moving. When this 1 is moving, this sign should change. Minus 1 and it's already minus 1 divided by 2. So I'll get minus 2 by 2, nothing but minus 1. So it is moving this side. So minus 1. then the corresponding element here it should be plus 1. You can see this way also. If you take this minus 1 hit this side, so it should change the sign, correct? No, so 1 remain 1. Minus 1 sign should change to plus 1 divided by 2. 1 plus 1 is 2. 2 by 2 what? 1. That's what we got here. Next. Now leftover choice. Let us go for the same. If I go this side, minus 2 will change to plus 2. Sign should change. Then plus 7 divided by 2. 7 plus 2 is 9. So 9 by 2. So we are going to have here 9 by 2. And the same here will be minus 9 by 2. Just see what in PUC we have did in so much. In one line answer it is. And here I have, since I'm teaching you and explaining you, so much time is taken. Otherwise you also know. We can finish. Let us see how many of you have finished before me and got the correct answer. Comment it. I would like to really know how many of you are working along with me. Okay. Kindly make a note, and how to know it's correct. If you add this, you should get back this. Anyway, diagonal is same, nothing to add because addition any number added to 0 is same number. Now here 5 minus 1 will be 4. 4 by 2 will be 2. Yeah, we got 2. 0 minus 1 is minus 1. 5 plus 1 will be 6. 6 by 2 is 3. Yes. Then this is fine. 5 plus 9. How much? 14. 14 by 2? 7. Yes. 0 plus 1 is 1. Then, okay, here. 5 minus 9 will be minus 4. Minus 4 by 2 will be minus 2. Yes, we absolutely got correct. Okay. Make a note of this.